Welcome friends. In this video we are going to look at random questions from science paper 2, where we are going to look at questions that covers grade 10 work. So let's look at the first question here. The diagram below shows how the molecules arranged in 3 states of matter. We have solid, liquid and gas. Then we have some change of state of matter. We have melting, process A, process C, process B. Now, question A, state the name given to the change of state labeled A. So if we look at labeled A, we are looking at the change of state from, this is a liquid. So we can see the way the particles or molecules are. So the molecules are just arranged to the bottom part. So we have the liquid, then here we have the gas. Now, by what process do liquid changes into a gas? So this is known as the evaporation. So we have evaporation as our first process. Then B, we are looking at the change from liquid to solid. And we know that whenever we put water in liquid state in a fridge, after some time you may find that the liquid water changes into an icy, which is a solid. So that is what we call solidification. Solidification or freezing. Then we have question B, describe the movement of molecules in a gas. So say molecules in a gas are free to move. Are free to move and in random direction. So if you look at the random direction, they have no specific direction. So let's say, if for example, if this is a container where we have these particles of gases, they have no specific direction. So this particle can go in this direction, this in this direction, this in this direction. So because of no specified direction, we refer this type of movement as random direction. Then C, which of the changes A, B or C is endothermic? Explain your answer. So let's go back to these 3 states of matter. So the first one, we know this is our solid, liquid and gas. So for solid to change from solid to liquid, the substance must be heated. So if you heat a substance, you apply heat energy. Then from liquid to gas also it has to be heated. Like for example, for water to evaporate, you need to heat water. Then inclusively sublimation. Sublimation, we know that it's a change of state of matter directly from the solid into a gas. So this is what we call sublimation. Also sublimation requires heat. Then what of the reverse? So the reverse is now like from gas to liquid, we have condensation. Now condensation, it is the reverse of evaporation, and this one, the substance must be cooled. Whenever you cool a substance, this is same as you remove heat. Then from liquid to solid, we have freezing or solidification. Now what of from gas direct to solid? This is what we call deposition. So remember, there is a difference between sublimation and deposition. Sublimation has to do with the change from solid direct to gas. Then the reverse from gas direct to a solid is what we call deposition. So the 3 above change of state of matter are all endothermic. Why do we say they are all endothermic? Heat is required. So whenever you look at endothermic reaction or process, you are looking at a process that requires heat for it to take place. Then the other three, they are all exothermic. So exothermic, we are looking at where heat is given to the environment. So remember, exo simply means to exit. Then endo simply means to, like, you allow something to come in or to enter. So we have at least now, so which of the changes A, B or C is endothermic? So which of the A, B or C is endothermic? So it's C. A is endothermic because we have saying for evaporation to occur, then heat must be applied. So say process A. Then reason, because heat must be absorbed from the surroundings. Okay, so now we move on to question 2, where we are looking at some apparatus used in the laboratory. So these are also questions that covers grade 10 work. So the table below shows some apparatus used in the laboratory. The first one, separating funnel, Liebig condenser, pipette, then desiccator, volumetric flask, laboratory thermometer, evaporating dish, Bunsen burner, and burette. State the apparatus used for the following. So the first one, burning and heating. So this is just the source of heat. So in our case, we have Bunsen burner. Then B, preparation of a standard molar solution. So preparation of a standard molar solution, we have volumetric flask. Then obtaining a distillate from a vapor of a liquid. So this is same as changing a substance from its vapor or its gaseous exchange into a liquid. So this has to do with the Liebig condenser, because the function of a condenser, it is to change a vapor back into a liquid. Then D, drying a substance or keeping them free from moisture. So that is a desiccator. Then measuring exactly 25.0 cubic centimeters of solution. So we can use a pipette for this. Okay, so now we move on to another question. The diagram below shows the cooling curve for a liquid. So the cooling curve describes, or it gives us the picture of how a substance is cooled. And if you look at the cooling of a substance, we are looking at what happens to a substance if a certain amount of heat is removed. So let's analyze this. So the first one, if you see this slanting line touching the x-axis, I mean the y-axis, and we can see that we are showing the cooling curve for a liquid. So if this is for a liquid, so for a cooling curve, we are saying we start with a gas. Then here at this point B, we know that for this one, we'll look at the change from gas, then into a liquid. From there, we'll look at from a liquid to a solid. So at this point, we know that the change from a gas to a liquid is condensation. So at this point, BC, this is where the condensation is taking place. So condensation is taking place, and during the process, we are expecting to have two states. So here we have a gas and a liquid. Then the point is, at this point B, this is where the condensation is starting. At point C, this is where the condensation is finishing, or it has stopped. So at this point, we are saying all the gas has been converted into a liquid. So D will give us a liquid phase. Now, let's look at some questions. So, in what state of matter is the substance in area A? So, area A, that should be a gas. So, this should be a gas. Then, what name is given to the point labeled B? So, point labeled B, at this point, we know that this is condensation. So, we have condensation point. So condensation point. Then in what states of matter is the substance between points B and C? So B and C, we are expecting to have two, which is gas and liquids. Gas stroke liquid. Then for D, explain the reason why the thermometer reading remained constant between points B and C. So between point B and C. So during condensation process, we are taught to explain why we think the thermometer reading remained constant. So during the process, whether it's a cooling curve or heating curve, during the process, the thermometer reading at that point remains constant. Now here, if we're looking at the cooling curve, the temperature is reducing. So if the temperature is reducing, now why has the temperature stopped reducing during the process of condensation? So where is that energy going to? So now the point is, if we have, let's say, a beaker like this one, and we have a thermometer. So when we have a temperature drop, the energy is given out. That's why the temperature is dropping. So the energy is giving out. That's why we say this should be exothermic kind of reaction. So the heat energy is giving out, and because the heat energy is giving out now, the temperature in the liquid is expected to drop. Now the question is, where is that energy going to during the process? So the point is, the energy is now used. So is used to bring the particles closer to each other. So the point is, if we have a gas, and we know that the molecules or particles in a gas are spacely packed. Now what are we supposed to do to convert this gas into a liquid? So what we are just supposed to do is, we just have to bring the particles closer, because the more you bring the particles closer, the more the state is changing. So if these particles were to be brought closer than the way they are in a gas, then the state will change from a gas into a liquid. So that energy that was being given out is now used to bring the particles closer. That's the reason why the thermometer reading at that particular time remained constant. Then for question A, explain what happens during cooling in relation to the heat content of the substance. So during cooling, you can now say the heat of a substance, So the heat of a substance reduces or drops. Why? We are saying it's exothermic. It's exothermic, whereby the heat is given out. Then for this graph, maybe if this question can also be read like this. Since we are told for a liquid, let's take if this is a liquid, what if we are beginning with the liquid instead of a gas? So if we are beginning with this point as a liquid, if we are cooling a liquid here, then at this point B will be the starting of freezing. Then this will be ending of freezing. Then here we are expecting to have a solid, which is the ice. So if this is the demand of this question, you need to answer it like this. Since if it is for a liquid, so for a gas, you begin with the gas, then we have condensation, we have a liquid. Then if you are beginning with a liquid here, remember, for a liquid to change from its liquid state into a solid state, we need to have freezing. So this point will be a freezing point. Okay, so now we have another question. Beryllium burns in fluorine to form a white solid, beryllium fluoride. The first one, name the type of bonding in beryllium fluoride. So before you identify the type of bonding, let's look at first which one. Do we have a metal or do we have just non-metals? So if you look at the periodic table, you'd find that beryllium is a metal, then fluorine is a non-metal from group 7. Now, since we are dealing with the bonding that is found or exists between a metal and a non-metal, then the name given to that bonding is known as ionic bonding. So we have ionic bonding, and ionic bonding has to do with the transfer of electrons or electrons from a metal to a non-metal. Now let's look at, in the space below, draw a dot and cross diagram to show the bonding in beryllium fluoride. Show all the electrons. So begin by first looking at beryllium. So beryllium is in group 2. It has the mass number of 9, the atomic number of 4. So if you look at the electronic configuration, we know that the first shell will occupy 2 electrons. Then if we subtract 4 minus 2, then the outermost shell will have 2 electrons. So let's look at the electronic diagram for beryllium. So first shell 2 electrons, then in the outermost shell we have also 2 electrons. Now let's look at the fluorine. So if you go on the periodic table, fluorine has the mass number of 19, then the atomic number of 9. So if you look at the configuration, the first shell 2 electrons, then 9 minus 2, we get 7. So this tells us that the outermost shell of fluorine will have 7 electrons. Now remember that the second shell is only filled if it has 8 electrons. So how many electrons are we supposed to give fluorine to become stable? So we can say that this fluorine, one atom of fluorine only need 1 electron to become stable. So now what will happen to the other remaining electrons? So what you do is this fluorine must call another, we can say another friend that will get the other remaining electrons. So that's a picture that I would like for you to have in mind. So this is coming here like this. So if we now finish this, our beryllium will be like this. So we just consider the outermost shell. So it is now stable. Then these 2 atoms of fluorines are also stable because their outermost shell are filled. So this is the picture. So the total charge for the two atoms of fluorine adds up to -2. Then this is now +2. Now remember, if we look at these, they are no longer atoms, they are now ions. So we have the first one, which is cation. We know that cation has to do with the positive. So the beryllium is a cation because it has a positive charge. Then fluoride here, we are going to have an ion since it has a negative charge. So this is the picture. Now let's look at if you look at the chemical formula for beryllium fluoride. So we know that beryllium is coming from group 2, so it will have a valence of 2. Then fluorine has a valence of 1. So if we use the crisscross method, this will give us BF2. So you can see the reason why we need 2. So these two atoms are these two atoms. That's a picture. So the summary that we can give here is the number of electrons that should be lost must be equal to the number of electrons that must be gained. So if we have an atom, if an atom that is gaining cannot receive the electrons that are being given out, that atom must call another atom or atoms in order to receive the other three. So maybe let's say we have aluminium. So I will just focus aluminium in the outermost shell. So aluminium, you has 3 electrons in the outermost shell. So let's say this aluminium is reacting with the fluorine, and we know that one atom of fluorine will only receive 1. Now what will happen to this? So this fluorine must call another 3 fluorines to receive the other 3. Thus the molecular formula, I mean the chemical formula for aluminium fluoride is this. So this is what the numbers represents under ionic. Then he suggests N2 physical properties of compounds that have similar bondings as beryllium fluoride. So the key point is we want to look at the physical properties of compounds that are ionic compound. So the first one, we can say it conducts electricity. When in molten state. Then the other one, it has a high boiling and a high boiling. So a high boiling and melting point. So we move on. Start the following list of processes: melting, chemical change, sublimation, condensation, evaporation, dissolving. Which of the processes listed above best describes what is taking place in each of the following? So the first one, formation of water droplets. So water droplets on a window and on a cold day. So that is condensation. So this is just the changing of a gas into a liquid. Then B, the formation of liquid. So the key here is liquid sodium chloride from a solid. So this is same as the change from solid to liquid. So this is melting. Then the formation of iodine vapor from iodine, solid iodine. So iodine vapor is a gas, then from a solid. So this is should be sublimation. That's why some of the questions that you may encounter is give an example of a substance that undergoes sublimation. Then the answer is we can just say iodine. Then adding sugar to hot tea and stirring it, that is dissolving. Then the formation of calcium oxide when calcium is heated in the air. So let's look at so this should be chemical change. It's a chemical change because it's not reversible. So we have chemical change. Then let's move on to another question from grade 10 work. Define the following terms. The first one, endothermic reaction. So say it is a reaction where heat is absorbed. Then exothermic, it is a reaction where heat is released or given out. So with exothermic reaction, you are expecting the temperature of the surrounding to rise because heat is given. Then for endothermic reaction, we are expecting the temperature of the surrounding to go down because heat is absorbed. Then B, give an example of each type of reaction in nature. So endothermic reaction, we can look at photosynthesis. So photosynthesis is an example of such a reaction. Why? We know that one of the requirements for photosynthesis to take place is heat. So photosynthesis requires heat energy, so it absorbs. Then endothermic reaction, endothermic is absorbed, where exothermic is given, that is respiration. If you respire, like for example, when you breathe out, you'd find that the air that we breathe out will come hot. So energy is given out. So respiration is an example of exothermic reaction in nature. Then photosynthesis is an example of endothermic reaction in nature. Describe the effect of exothermic reaction in industry on the environment. So remember, exothermic reaction, we are saying heat is given out. So let's say if we have this is the system. The system in science refers to where the reaction is taking place. Then this is the outside or the environment. So if heat is coming from this system given out to the surrounding, what do you think will happen to the surrounding? So the temperature of the surrounding will rise. So say the temperature. So the environment is the surrounding. So the temperature of the environment increases. So there is a rise in temperature. So exo given out, rise in temperature. Endo absorbed, then a drop in temperature. Then we have question 8, which is also grade 10. Give 2 reasons why chemistry is important in industry. So the first reason, we can just say chemistry is used to make fertilizers. So we use chemistry to make fertilizers. Then chemistry is used to make cosmetics. That's chemistry. Chemistry is used for water purification. That's chemistry. If you look at fraction distillation, where we have petrol, diesel, that is chemistry. So chemistry plays important roles in human lives. Then state any two laboratory safety rules. So the first one that we look at is we can say wear goggles. Then where okay, let's not use where, but let's say do not eat or drink anything. In the laboratory. So there are so many laboratory safety rules, like avoid running, like do not anything without the supervision of someone in charge. So that is the point here. Okay, so we move on to another question. The diagram below shows one of the laboratory apparatus. So this means that as you are studying and preparing for your exams, make sure you also have to look at the structure, how to identify an apparatus based on its appearance. Like the question that we are given here is name the apparatus. So what do you think this apparatus is? So please make sure as you are studying, you need to look at this structure. So this structure is known as the separating funnel. Then B1, state the use of the apparatus shown above. So say to separate immiscible. So immiscible liquids are liquids that does not mix completely. Suggest two substances that can be separated by the apparatus shown above when combined. So remember to give substances that cannot mix, so which is water and cooking oil. How do you know? How can you know that the given compounds, for example, the given substances are immiscible? You just have to look at the density. So if they have different density, then one substance which is lighter will be on top. So for example, cooking oil is lighter than water, so its density is smaller, and we are expected it to be on top. So if these two are put in one beaker, then cooking oil will be on top because it is less denser. Then our water will be on the bottom part. So that's a picture here. Then we go to question 3. In chemistry, substances are classified as elements or compounds. Distinguish an element from a compound. So say an element is a pure substance. It's a pure substance which cannot be broken down. While a compound is a mixture. So it's a mixture of two or more elements that are chemically combined. Two or more elements that are chemically combined. Then the table below shows the chemical formulae of substances. We have ammonia, hydrogen, sulfur dioxide, O2. Then from the table above, classify the substance into elements and compounds. So the compounds, we have ammonia is a compound because there is nitrogen and hydrogen. Sulfur dioxide is also a compound since we have two elements. Then elements, we have hydrogen is just an element. O2 is also just an element. So elements, we are just looking at a substance that has one kind of atom. Then a compound, we are looking at substances that have two types of atoms. Okay, so we move on. Matter is made up of three basic units. State the three basic units of matter. So the first one, we have ions. Then we have atoms. Then we have molecules. So don't confuse ions with basic states of matter. So basics are these. Then states of matter are solid, liquid, and gas. Then give the basic units of matter contained in a common salt. So in a common salt, we have the sodium chloride. And if we break these two ions, this compound will give us two ions. There is sodium plus ion, then there is chloride ion. So since these are ions, then the basic units of matter contained in common salt, we have ions. Noble gases like argon are made up of one of the basic unit particles. So state the basic units particles in noble gases. So noble gases are just group 8. Then under group 8, we know that they are monoatomic. So monoatomic, it means that they are just made up of one atom. That's why we say they are stable. They cannot be found in a compound. So the basic units of matter that can exist there are just what? Atoms. Then we have another question. The table below shows the description of substances A, B, and C. Give the physical state of each of them. Then description, state of matter. So the first one, particles occupy any space available. So it doesn't matter the size of the space. So this is a gas. A gas behaves like this. There is no specific or shape and size. Then particles closely packed. We know that this will give us a solid. Then particles move randomly within the spaces of the substance. So we have a liquid. How can substance C attain the structure of substance A? So what is substance C? Is a liquid. Substance A is a gas. Substance C is a liquid. So the question, how can substance C? So let's view it like this. So how can substance that is in liquid attain the structure of substance that is in a gas? So how can we convert a liquid into a gas? So we'll say by evaporation. Then substance B is said to be a pure substance. Give one characteristic which proves that B is a pure substance when melting. So pure substances pure substances have fixed melting point. So say substance B has a fixed melting point. Now impure substance may have the melting point below or sometimes greater than the norm. Then B3, the diagram below shows how atoms of sodium and chlorine, okay? State the type of bonding that exists in the compound formed when the two elements combine. So sodium is a metal. Chlorine is a non-metal. So we've said this before. A metal and a non-metal forms ionic bond because there is a transfer. Then draw the structure of the compound formed when sodium. So if you go on the periodic table, sodium has the mass number of 23, atomic key of 11. So first shell is 2. Second shell will give us 8. 8 plus 2 is 10. So the outermost shell will give us 1. So first shell of sodium, we need to put 2 electrons. And under this one, this will be a 1-to-1. So 1 atom of sodium needs 1 atom of chlorine. Why? The number of electrons given is equal to the number of electrons received. So no need of 1 to call the other one. Then if you look at the Cl 35.5, the mass number, then the atomic is 17. Remember, we use the atomic key whenever we are dealing with bonding. Mass number is used for calculation. So 17, first shell 2, the second shell 8, 10, so the outermost shell is 7. So Cl, first shell, we put 2 electrons, then the outermost shell will have 8. Sorry, the second shell, since the outermost will have 7. Okay. Then our third shell, which is the outermost shell now, will occupy 7 electrons. So this one will now be transferred here. Then this will give us, we just consider sodium, the first shell, then the second shell. Let's just forget about the third shell since it's stable now. Then for Cl, then we put this. So now we have our diagram as required. So where there is the chlorine, we put -1. So this means that the negative means it has gained 1. Then the positive 1, it has lost 1. So this is the sodium ion because it's stable. Chloride ion, it is stable. So to differentiate, we put an ion. Then here we put cation. Then these are known as monovalent because they are dealing with 1 electron to become stable. Then state the chemical formula for sodium chloride. So sodium has a valence of 1 from group 1. Chlorine has a valence of 1. So these would be 1-to-1. Then explain in terms of bonding and structure why sodium chloride has the following properties. A very high melting point. So because of the strong forces of attraction, between sodium ion and chloride ion. We know that like charges repel and like charges attract. So these two will have a force of attraction, and in order to break that force of attraction, a large amount of heat must be applied. That's why we have a very high melting point. Then high electrical conductivity when in molten. So we'll say because of the free movement of ions. Okay, so we have another question. The table below shows some common gases and their particulars. So we have gas, ammonia, carbon dioxide, carbon monoxide, helium, nitrogen. Relative molecular formula mass, we have 1744, 24. So choose from the list given the gas or gases that best suits the following description. A gas may be chosen once, more than once, or not at all. So the first one, the gas that diffuses fastest. So for you to identify the gas that diffuses fastest, you need to look at the one that is the lightest. So how do you know that this gas is the lightest? You need to look at its mixture. So from the table, we can see that helium has relative molecular mass of 4 and vapor density of 2. So this is the lightest one. So we'll say helium. The names of the gas that diffuse at the same rate. So to diffuse at the same rate, they need to have the same mixture, then also vapor density, because this means that they have the same weight. So let's look at the carbon monoxide has 28, nitrogen has 28. So same, let's look at 14 and also 14. So it's carbon monoxide and nitrogen. Then state the name of the gas that will diffuse faster than any other gas, not other shown in the table. So that is just hydrogen. We know that hydrogen is the lightest, because if you look at hydrogen with the mass number of 1, the atomic number. So if we have this hydrogen, the atomic, so if we are to find hydrogen, we'll say 1 times 2. So this will give us 2. So then the lowest from the table is 4. So you can see that hydrogen is the lightest gas. So in terms of the diffusion, this would diffuse fast. Then what is the relationship between relative molecular mass of the gas and its vapor density? So let's look at these numbers in our table here. So you can look at ammonia 17, vapor density 8.5. Let's look at carbon dioxide 44, vapor density 22. So if the relative molecular formula of the gas increases, its vapor density increases also. So we'll just say molecular formula mass is directly proportional to its vapor density. Why? If the relative molecular mass increases, the vapor density will also increase. So whenever we have a relationship where one variable increases, the other one also does the same, that's a directly proportion. Then under what condition would carbon dioxide diffuse faster than ammonia, both of equal volume? So when carbon dioxide is heated. So the question is, how can you make something that is heavier than another substance diffuse faster than something that is lighter? So you just have to heat. So whenever a substance or a gas is heated, it becomes lighter. Then you have B2. The diagram here shows the preparation of liquor in a village. Okay. Then we have mixture of ingredients. Okay. Name the process demonstrated above. So this is it. Fractional distillation. And the other way we can say this fractional distillation is dealing with fermentation, because we are looking at formation of alcohol. Then name apparatus B. Apparatus B, so this is a gas. So which apparatus converts a gas back to liquid? So that is just a condenser. So we have a condenser. Then if this experiment was done in the laboratory, in the school laboratory, what name would be apparatus A and B. So apparatus C A would be round bottomed flask. Then apparatus C B, which is the condenser. So in the lab this would be Liebig. So Liebig condenser. Then what is the scientific term for the liquor or liquid in the experiment? So this is ethanol. Remember, ethanol is the only alcohol that can be produced by fermentation. Okay, so now we move on to another question. A learner carried out a chromatograph experiment to identify components of substances X. Water was used as a solvent. The results of the experiment are shown in the chromatogram below. So we have the starting line, then the solvent here. The distance from the starting line up to the solvent is 28 here. Then we have the distance from the solvent front to the highest point by which these dyes moved. Okay, so let's look at the first question. Which one of the components A, B, or C is insoluble in water? So insoluble, we are looking at a substance that did not or that cannot dissolve. Now, how do you tell by a chromatogram that this substance is insoluble? You look at the one that remained on the starting line. So we can say that A did not move. So this means that it didn't dissolve. So we say substance A. Then explain your answer. Because it remained on the starting line. Remember, starting line is also known as the Dantam line. So if you found a Dantam line, please never be confused. Then B, which of the unknown component or components was or were not contained in substance X? So let's go back to so this is our substance X. So substance X has only one spot. Then let's look at the height of substance X and substance B. So we can say that substance B moved the same height as X, so B was part of X. Now C, we can say that C, there is no spot here, so C was not part of X. Then let's look at what else. A, there is nothing here, so A and C were not part of. So this is how you can tell by using a chromatography. So you have to look at the heights, the movement of each spot, then you'll be able to tell that this substance did not move. So say A and C. Then calculate the retention factor value. So what is the formula? So say RF, retention factor, is equal to distance moved by component over distance moved by solvent front. So let's go back. So the distance moved by the solvent front is this distance here. So it's 28. Now the distance moved by the component is this distance. So we need to find this distance. So we know that the distance from here up to here is 28. Then from here up to here is 7. So we just have to find the difference between 28 and 7. So we'll say 28 minus 7 will give us 21. So this means that there was 21 centimeter here. So it's 21 centimeters over 28. Remember, it's a ratio, no units. So the answer is 0.75. Then the other questions that you may expect under chromatography is maybe the practical use where these are used. So we know we look at separation of colors. Then also in food tests is used also to check the counterfeit in terms of money and so on. Okay, so we have another question. The following table shows the structures of 4 particles P, Q, R, and T. So the word particle means same as the atom, because we define atom as the smallest particle. So don't be confused whenever you hear particles in science. So the first row we have particles. The second one here we have protons, neutrons, electrons. So which particle is a neutral atom? Remember, for a particle to be neutral, the number of protons, which are positively, must be equal to the number of electrons. So look at the P. P has 11 protons and 11 electrons. So P is neutral. What else? Q has 11 protons and 11 electrons. So P and Q, these two are neutral. Which particle is a negative charged ion? State its charge. So for a particle atom to have a negative ion, the number of electrons must be greater than the number of protons. So which of R or T? So let's look at R. R has 12 protons and 10 electrons. So this one, for R, we can see that the number of protons are greater than the number of electrons. Then for T, we can see that we have 8 protons. So protons are less than the electrons. So then one with a negative charge is particle T. Then the charge, just have to look at the difference between the protons and the electrons. So it's 10 minus 8, which is giving us 2. Which 2 particles are isotopes? So what are isotopes? Isotopes are compounds, or I mean not compound, but elements with the same atomic number but different number of mass numbers. So which of these can be this? So let's first look at P. So P, how can we find the mass number? For us to find the mass number, we add the protons plus the neutrons. So 12 plus 11, we get 23. Then the atomic number is just the number of protons, which is 11. Okay. Now let's look at our Q. Q it is 11 plus 13, which is 24. Then here we have 11. So you can say that Q and P are isotopes because their atomic number are the same, but their mass number differs. So it's P and Q. Reason? So because they have same atomic number. But different number of neutrons. Then use the periodic table to identify particle R. So let's go to R. So R, let's find the mass number. So it's 12 plus 12, which is 24. The atomic number is just 12. So remember, the atomic number is just the number of protons. Don't look at the number of electrons, because the number of electrons can change, but the protons does not change. So if you go on the periodic table, this is magnesium. So magnesium has 12 as the atomic number. So we have magnesium. Okay, so we have another question. Figure 2.1 shows a separation technique used to separate miscible liquids. So what are miscible liquids? These are liquids that mix completely. So these are what we call the miscible. Now let's analyze these. Okay, so the first one, what is the name of this separation technique? So we are dealing with fractional distillation. Okay, then what is the purpose of glass beads in the fractionating column? So let's see if we can have a picture of this. So you know that if the mixture has let's say water plus ethanol, so ethanol boils at 78 degrees Celsius, water at 100. So if this mixture is heated, ethanol will start to evaporate before water. So during the evaporation, as the ethanol is rising, sometimes the ethanol molecules may rise with some of the water vapor. So now what we want is we just want one substance to move in this. So the function or purpose of glass beads is to convert the water vapor that may be risen with the ethanol back to liquid, so that the water vapor may go back into the mixture. So that is the importance of that. So to remove any we can't, let's not say any water vapor. So to remove any substance that we want to remain. We want to remain in the flask. So there is a substance that we want to go and the one that we want to remain. Why is the Liebig condenser kept in the slanting position as shown in the slanting? So the slanting as shown. So to allow liquid to move. So to allow liquid to flow. Apart from the mixture of miscible liquids, name two other mixtures which can be separated using this separation technique. So like here we have crude oil. Crude oil can be used to separate this. Then also liquid gases, like if they are separating oxygen from carbon dioxide, this is what they use. So A1, give one reason why laboratory rules are very important. So to prevent accidents. State one importance of chemistry in our day-to-day life. So to make fertilizers. Then for cooking we use chemistry also. Washing, cleaning, that is chemistry. So there are so many. Then let's look at it. The following graph shows heating curves that were drawn after pure ice and candle wax were heated over time. So identify so here there is a pure ice and candle wax. So candle wax, we'll just consider this one to be impure. Then identify the heating curve for the candle wax and give a reason for your answer. So candle wax is curve X. Then the reason we can see that the line is not straight. So the graph is not linear, showing that the substance has some impurities. So whenever you are trying to identify the purity of a substance, you just have to look at, in terms of the graph, if the line is straight, then that's a pure. If it's not, then it's impure. Then give one effect of impurities on the melting and boiling point of a pure substance. So it may lower the boiling, let's say melting. It may lower the melting point and increase the boiling point. Study the following flowchart and answer the questions that follow. So we have liquid P plus liquid Q is equal to mixture Q, not distinct layer seen between P and Q. So this shows that these liquids are miscible, so they are able to mix completely. Then so let's look at what are liquids P and Q in the mixture called miscible. We are told no distinct layer, you can't see the difference. They are form one uniform. Then what is the separation technique? Give the criterion used to separate the mixture. So the separation technique is fractional distillation. Fractional distillation. Criterion, it is about the temperature, difference. deduce the names of liquids P and Q. So P can be water, Q can be ethanol, because water and ethanol mix completely. Then we have B3. The following symbol shows a nuclide of element A. Okay, distinguish between the numbers 16 and 32 shown. So say 16 is the total number, of protons, while 32 is the total number of protons and neutrons found in the nucleus of an atom. To which group of the periodic table does element A belong? So how do you define the group? So you write the configuration for this one. So the first shell will occupy 2, 16 minus 2, we have 14, we have 8, then 6. So group 6, because there are 6 electrons in the outermost shell. Use the periodic table to identify element T. Yes, so according to the periodic table, with this number is sulfur. Draw a dot and cross diagram to show the bonding formed in A compound between A and hydrogen. So we know that hydrogen has a valence of 1, sulfur 2. So this will give us dihydrogen sulfide, which is sulfur will be our central atom, first shell, second shell, third shell. So 1, 2, 3, 4, 5, 6, 7, 8. Now whenever you are dealing with a covalent compound where you have hydrogen, just remember that hydrogen will just form one bond. Hydrogen has a valence of 1, so you only form 1. So just know that here where the hydrogen will be sharing, we are just going to have 2 electrons. So for hydrogen, it's simple and straightforward. The hydrogen will bond with another nanometal and it will have 2 electrons. Then compare the bonding in the compound formed in C1 with that in calcium oxide. So the bonding in calcium oxide is anionic, while the bonding in C1 is covalent. If you want to use this, you can just say the bonding in calcium oxide involves the transfer of electrons, while in C1 the sharing. Okay, so now we have another question. The following experiment was set up to investigate factors that affect the rate of diffusion in gases. During the experiment, a cloud of white smoke was seen as the ammonia gas NH3 and hydrogen chloride gas HCl reacted. So what is our first question? Define the term diffusion. So this is the movement of particles from the region of higher concentration. To a region of lower concentration. Then which of the particles for ammonia or hydrochloric acid will move fast? So remember, ammonia is here, so ammonia will go in this direction, then HCl will go in this direction. So at each point the ammonium is at a higher concentration, so it has to move in the lower concentration, also this. So we want to look at which of these will move the fastest. So for us to know the gas that will move the fastest, you need to look at which one is lighter and which one is heavier. So ammonia, we know that ammonia is NH3. So if we are to solve for Mr. ammonia is N times 1 plus C hydrogen times 3. So N is 14 times 1 plus 1 times 3. So 14 times 1 is 14 plus 3. This will give us 17. What of HCl? So HCl Mr. is equal to hydrogen times 1 plus Cl times 1. So hydrogen is 1 times 1 plus 35.5 times 1. So 1 plus 35.5, which is 36.5. So you can see that HCl is heavier than ammonia, so ammonia will move fast. So that's what you do. So the answer here is ammonia. So you just go with the one with the lowest number. So at which point A to D along the tube T will the white cloud be seen? So the white cloud is just the product of ammonium chloride. So where will these two collide? So 17 is just the double of 36. So this will cover a distance. So this is the half. So they will meet somewhere here. This is where they would like. So ammonia, since ammonia will move faster, it will cover the double the distance this will cover. So that's a point. So we can say C, this is C or D. C or D. Explain your answer. So this is because ammonia will cover a greater distance. State the fact that affects the rate of diffusion in the experiment. So in the experiment, the factor that so what we are looking at here is just the concentration. I mean, not concentration, since it's the size. So say size of the particles, because of the reason why we say this, because we looked at the one which is heavier, so it's a size. Then safety precaution you would take when carrying out, so by wearing goggles and mouth mask. Why? Ammonia is poisonous, so we need to make sure that you prevent it from getting into that. Then we have the following some common substances. Okay, then choose from the above list a substance which is the first one, compound containing 3 elements. So 3 elements, we have limestone. Limestone has 3 elements. We have calcium, carbonate. So there is calcium, there is carbon, there is oxygen. Then what else? Sugar. You know that in sugar we have C6H12O6. There are three. Mixture of two elements. So mixture of two elements, that is brass. Mixture containing both elements and compounds, that's air, because in air we have carbon dioxide, we have oxygen. Mixture of compounds, that is petroleum, because in petroleum we have ethane, methane, petrol, diesel. Then let's look at the last question here. Atoms J and K have 8 and 12 electrons respectively. So J 8, it's 2,6, K it's 2,8,2. So determine the formula of the compound formed by the combination of J and K. So these two have the same valence, so it will just be JK. Now let's begin with K. K is a metal because 2 electrons in that atom, so we say KJ. Then if JJ, so we have this will give us a diatomic. In each of the cases shown in, name the type of bonding found. So ionic bond in KJ, covalent bond in J, or diatomic. Give 2 physical properties of the compound formed in A1. Have high melting and boiling point. Then it conducts electricity. These are just the ionic compound in molten state. So this is what I can share for you guys for this video. So consider this video as part 1, because most of the questions that we have looked at here are from grade 10 work. Then we'll proceed by look at grade 11, look at grade 12. Then I'm sure my plan is I want to make a video for organic chemistry, questions for organic chemistry on its own. Then we'll see. Then remember the emphasis that the revision is just to give you ideas on how question comes, then how you should do handle these questions. So never expect the questions to come exactly. So science is a sensitive, very sensitive subject that requires for you to move out of the box in order to answer this. So that's it for this video. Thanks for watching.